Alright, some set of students asked me to make a video on gas laws, and in this video I'll be making justice to that, and I'll be explaining everything you need to know about gas laws. It is very easy. Let's do it together. Now, the first one we'll be talking about is Boyle's law. Now, Boyle's law is comparing what we call pressure and volume. So it states that the pressure of a fixed mass of a gas, right, at a constant temperature is inversely proportional to the volume. Okay, so some people, you can define it in different ways, but what it's just trying to say is that the temperature must be kept constant while the pressure is inversely proportional to the volume. This is a very good analysis. It's a very good concept. Now, for instance, let's say you have just this small room and you have, let's say, 1,000 people staying in this room. Now, because the particular volume here is very small, the pressure that will build up in this room will be larger. So small volume, larger pressure, right? But let's say you ask just one person to stay in this room, or you just ask that same 1,000 people to be on a field. Now the volume is larger, so the pressure will be small. So that's a very just analysis that you can just use to understand this. Another way you can also use is when we have a particular volume of water. Now let's say you are boiling a particular quantity of water, right? Now if the volume is larger, the pressure that will be built up in the molecules will be smaller. If the volume is small, the pressure that will build up in that molecule will be what? Higher. So that's just the concept. So if we have this, don't forget, in our secondary school, if you want to change this into an equal to sign, this is a proportionality sign. If you want to change to an equal to sign, there must be a constant K, okay, or all over V. Now that means if you have this, that means I can tell you that PV equals to K. Abi? So that means this is just comparing one when we have just one thing. So if you now have a constant, it means I can say P1 V1 equals to P2 V2. So this is what Boyle's law is talking about. Okay, so that means this constant is the what? Is the temperature here, because they said provided the temperature remain constant. So this is Boyle's law. So take note of this. So that's the first equation we'll be writing. P1 V1 equals to P2 V2. Now, the second law is what we call Charles' law. Charles' law. Okay. What Charles' law is actually talking about? Charles' law is comparing volume and temperature. He's saying that the volume is actually directly proportional to the temperature, provided the pressure remain constant. So if this is this, that means if I have V equal to, I'm converting this proportionality sign to an equal to, that means there must be a constant K, Abi, KT. So if I have this, this is not what is equal to a constant. What is equal to a constant is actually V divided by T. This is what is equal to a constant. So in this case, I can say if I have 2, it should just be V1 over T1 equals to V2 over T2. So that this is what Charles' law is saying. Charles' law is talking about. Now, don't forget that this temperature here, they must be at a particular unit. They must be in Kelvin. Now, you will understand why this is so. They must be in Kelvin. Okay. Now, also, I will talk about the graphs after this. I'll talk about the graphs. I must talk about the graphs. It's very, very important because people used to miss it. So that means this must be in what? In Kelvin. There are different units of temperature. We have Kelvin, we have Celsius, we have Fahrenheit. I will still talk about this. Fahrenheit. We have Reaumur scale. Reaumur. You get. We have Rankine. They might not ask you this one, but the one you should know is Kelvin, Celsius, Fahrenheit. But if you are preparing for post-UTME, you should know Rankine, you should know Reaumur. So don't worry, I will talk about temperature scale. I will talk about it maybe after this video. Okay, so now this is the second formula that I need. This is for Charles' law. Okay. Now, the third formula is talking about pressure law. Okay, pressure law. In physics, pressure law is what we call Gay-Lussac's law in physics. But pressure law is different here. This is chemistry. It's different in chemistry. You understand? So pressure law, Gay-Lussac's law, they are two different things. But in physics, pressure law is what we call Gay-Lussac's law. But in chemistry, Gay-Lussac's law is trying to talk about gases when they combine in simple whole number ratio. Okay, but pressure law here is just trying to talk about pressure and relationship with what? Temperature. So it's saying that pressure is directly proportional to temperature provided the volume remain constant. So if that is so, then I have a proportionality sign. If I'm converting this to this, there must be K. Then P over T must be equals to K. Then if that is so, I can say P1 all over T1 equals to P2 all over T2. So that means that's another formula. So that's the third formula that we'll be needing. P1 over T1 equals to P2 over T2. Now, if you look at this very well, if you look at this thing very well, you would agree with me that if I combine Boyle's law, Charles' law, and pressure law, I will get something. Look at it. P1, V1, Abi, there is V already, there is P already. That means if I combine these two with this, that means what is left is just T1. So that means this itself can be equal to a constant. Abi? So that means I can tell you now that P1 V1 over T1, if I'm comparing, if I have two, that will be P1 V1 over T1 equals to P2 V2 over T2. So this is general gas equation. General gas equation. Okay, so when we have P1 V1 T1 P2 V2 over T2, I'm very sure I know you have seen a particular formula like this. You also agree with me that I can say P1. Now don't forget, there's a Jamb question that pressure times volume equals to K. That this thing, this is supposed to hear me, is equal to work done. This one, I just want to chip in this. Now, how? Don't forget that pressure is force over area. And volume is what? Area times height. So that means I can say area will cancel area. Why? Because don't forget, this is like cm cube. And this is what? Pressure, force, that's Newton per meter square. Okay, why this one can be meter cube. So that means if this cancel this, it's like having force times distance. So which is equal to what? Work done. UI post TME. They ask this particular question. So I'm just chipping in. Jamb can ask you this, especially when they're talking about dimensions in physics. So this is very, very important. Please don't forget. So Boyle's law constant is work done. Jamb question. Now let's move from there. So if you understand this, that means I can tell you now. You know, I said this is equal to a constant. I can say P1, PV, right, all over T can be directly proportional, Abi, to, let's say, N, for instance. So if this is this, I can say PV over T. We can now have a constant. So that constant is what we do call gas constant N. Abi? So that is where you see a formula that says PV equals to what? nRT. So what do you need? These are the formulas you need. You need this. So we start from here. Boyle's law, when there is a pressure P1, V1, and they give you P2, they have to calculate V2. You can use this. When they give you V1, T1, V2, they have to calculate T2. When they give you P1, T1, P2, they can give any of these. They have to calculate the other one. And they can also give you, when they are talking about general gas equation, when they will give you let's say the pressure at STP. That's why you have to also understand what they mean by at STP. At STP, the word STP means standard temperature and pressure. So there's something called at STP. Now, at STP, it depends on what the pressure or the volume is being given. Okay, it depends on what the pressure or the volume that is being given. Okay, but don't forget that at STP, the temperature here is 273 Kelvin. That's the first thing you have to understand. So if I give you this particular one at STP, what will be the temperature? 273 Kelvin. While the pressure at STP is 760 millimeter of mercury. Now, this thing can be equivalent to other unit of pressure. This particular one can be 1 atmosphere. Okay, it can also be 1.0132 times 10 to the power 5 Newton per meter square. So it depends on the unit. But just know that this is 273 Kelvin. This is 760 at STP, standard temperature and pressure. So they might ask you to now calculate, maybe they will not give you other particular unit and ask you to other particular quantity and ask you to calculate its equivalent. Okay, so this is the explanation for this. Okay, now the next one I will be explaining is graphs. So please don't forget, note this: PV equals to nRT. Note this: P1 V1 over T1 equals to P2 V2 over T2. Note P1 V1 P2 V2, V1 over T1 V2 over T2, then this. So these are the 5 formulas you should know. And this, okay, now please, there's no degree Celsius here. Kelvin is just as this. The next one I'm talking about is graphical representation of these particular laws. Okay, graphical representation of these particular laws. Now let's go. Now, how do you represent them on a graph? I don't know why people used to miss the graphical representation, but it's very easy. Another formula: P1 V1 over T1 equals to P2 V2 over T2, then PV equals to nRT. Now, let's start with Boyle's law. They said P is inversely proportional to volume. That means, look at it. If I have a graph like this, such that P is here and V is here, now it can't be a straight line. Why? They didn't say P is directly proportional to V. They said P is inversely proportional to V. That means when this guy increase, what happened to this one? It must decrease, right? So look at this. Don't forget, this is 0.00. So that means this one is 2, 4, 6. I'm just going to be using 2, 4, 6. Let's say this is 8 and this is 8. That means if this one is 8, what do you expect this one to be? It should be 2, because they say it's inversely proportional. So when this one is 6, this one should be what? It should be 4, right? It should be 4. And when this one is 4, this one should be 6. Look at it. When this one is 2, this one should be what? It should be 8. Okay, that means I can say P inversely proportional to V can simply means when you have something like this, right? It can simply means that. So, or look at it. I can say P when I plot P against 1 over V. P is actually directly proportional to 1 over V. So in this case, I can have my straight line graph. Is it not simple? When P is plotted against V, is this. Okay, it will be this. Look at it, it will be this. But when P is plotted against 1 over V, look at 1 over V, and the law states that P is directly proportional to 1 over V, I can state it like that. Or P is inversely proportional to V. So if I'm saying 1 over V here, it will be a straight line graph because of this directly proportional. So these are the graphs for Boyle's law. Okay, depending on which one they give you, just be careful of this. Now, Charles' law. Charles' law is very easy. You will see now. Now, let's say I want to plot a graph of Charles' law. Now, Charles' law, since it is actually V is directly proportional to T, that means I can say V against T, right? So I can say because V is directly proportional to T, but there is a particular temperature here, minus 273, right? Now, if it is minus 273, there's something you have to understand. Conversion scale. T Kelvin is 0 degrees Celsius, or a value T degrees Celsius plus 273. This is the conversion scale. We've not talked about conversion though. I'll still talk about that. That means minus 273 degrees Celsius, if it's here, that is eventually what is actually equal to what? 0 Kelvin. That means minus 273 degrees Celsius is actually equivalent to 0 Kelvin. How? Because I know T Kelvin is T degrees Celsius plus 273. So if I add minus 273 here, actually, this thing is not actually minus 273. It is minus 273. It is 273.15. If you get to UI, like when you get to advanced, but for your level, this is what they do. So take it like this. So if I add that here, that means minus 273 plus 273 will give what? 0 Kelvin. So it's equivalent. So at this point, there's so I can have this, then this. Okay, this can be a graph representing this. Like when it is starting from -273, of course, you can't expect this is negative axis of the Celsius, while this is positive axis of the Celsius. That's why I'm starting from this. You understand? So this is a graph representing volume against temperature for Kelvin. Okay. Now, I don't want to talk about this. There's a particular concept of absolute zero, and where talk about where the volume of heavy gases tends to cease and tends to be zero. Okay, it is at this temperature. You understand? It is at this temperature. So I don't want to bore you with so much stuff. So that's why I'm taking it little by little. Now, another thing that you also have to understand is that if I have, let's say, pressure is directly proportional to temperature, absolutely, if I'm plotting a graph of P against T, it will be like this. Easy. That means it's saying when this increase. So let's say I have 8, I have 8, I have 2, I have 2. When this increase, Abi. So that means this is what you'll be having. Abi now. When this decrease, this also decrease. So eventually, if you plot them together, so that's why you have that straight line graph. I'm just giving you a hypothetical way to know it. So that explains that. So these are graphical representation of this gas loss. So I hope you understand this, and I hope if you see these questions inside your exam, you'll be able to solve it. So if you have not joined our class, we've been organizing, we started since January, where we'll be teaching people student writing Jamb. Try to reach out, send me a DM wherever you're listening to this, either on YouTube or on TikTok. Send me a DM so that we can add you to the class group. So where I'll be teaching you all you need, all your subject combination. So see you in my next video. Bye for now.